Welcome back, machine learners. It has been 45 minutes on the dot. Our algorithm has trained, it's learned, it's taken in our disaster data set, and I think we should look into what the results are. Now, you might be overwhelmed with all of these different lines of code and outputs. That's okay. What each of these are demonstrating is one epoch, which means one round of training. So as we can see here, it stopped at 202 rounds of training or epochs, and that's okay. Why it stopped? Well, this notebook will automatically stop training if there is no improvement to the notebook. Well, that's not preferable, but that's okay for our purposes of learning how to get this process started. When you're trying to figure out, okay, it stopped and what happened? What is the result of this training model? We can go on to the next steps of the notebook. We'll help evaluate how the YOLO performance did. So I've already loaded and launched it, but feel free to hit play. It'll take just 5 seconds for me to load what these metrics are to evaluate YOLO and evaluate that algorithm that we just developed for disaster damage detection. So here we have different metrics. To break it down, MAP_05 is going to be our accuracy. This is the #1 indicator of how well the model is performing. We have quite a varied amount of success as you drag your cursor in and along here. So as we can see from our accuracy, we have moderate success. What are some other ways to tell if our model is performing correctly? Well, we have accuracy, averaging at about 40%, which isn't too high, but we also have precision to look at. What precision is detecting is how well those bounding boxes are finding those homes and structures. Recall is also another metric. This is a great metric for the purposes of applying and deploying these types of machine learning. What recall is, this metric, what it's giving us is how well the model is seeing a random photo, a blank, unannotated photo, and detecting damage without any information, right? So we're training it on pre-annotated labeled photos, but how well is it able to do that as if it saw no bounding box, as if it saw no label? And this is a great metric. We're reaching some high numbers. Definitely dropped down after a couple rounds in epochs, but that's okay. Now, don't be discouraged. This model, it's only 800 images. It's the best that our researchers could collect and could accomplish now. This is cutting edge technology. So it's only going to improve from here. The more we train our models, the more data we give it, the more robust we make these methods. Perhaps we change annotation methods. Perhaps we tweak what model we use. For right now, this is YOLO, and our tensor board is a way to see how that works. Now, there's other features of the tensor board, such as clicking on images, which will give us some more detailed graphic depictions of its accuracy, more graphs and whatnot. For the purposes of just understanding and getting into machine learning, let's jump down here to understanding and assessing how we can deploy the model. So, right, we have our disaster trained model. We know that a disaster is upon us. We start collecting images after the disaster hits. And now we want to say, hey, we have all these homes. We don't know who's damaged, who's not. We have thousands of homes potentially damaged. Let's run them through and see how our model can help detect that damage. So here we're just going to hit play, and what this is going to do is it's going to run all of those weights through and really understand and assess from our test images. So you can see here it's going through and it's attempting to do and detect damage. Remember, if you need to get file names consistent, every result here is going to be saved in runs, detect, and experiment, I'm pretty sure. And those can be found on the folders on the side. If at any point you need to go back and check, oh, was my data set uploaded correctly? Is this correct? Is that correct? Come over here. This is where our libraries are, and this is where all of that setup, installation, and requirements are in our data set. Right now, I know it's runs, detect, exp. Well, this is great. We have just line by line of whether the images that we tested it on are actually damaged or not. But like, what if you wanted to visualize that? What if you wanted to see the bounding box on the image?